All right, Pete, are you ready to start? Sam, are you ready to start?
Yes, go ahead.
All right, so I want to welcome everybody to this Rings workshop, Vision Learning and Data Sets, Vision Teaming and Data Sets. And the co-chairs are Pete Gupta of UCSB, who's been an awesome co-chair. He's done most of the heavy lifting. And I'm Katie Wilson, and I'm from Santa Clara University. So the brief introduction will first say welcome. And I also want to introduce to you Ms. Sam Trevino, who is doing a lot of the wonderful controls here. And she is helping keep things running smoothly. So let's give her a round of applause. And then I'll go through the agenda and a few house rules. So this workshop is organized by the NETS virtual organization. This is a new organization. I'm the PI for it. And we have a logo that we're working on that you can see up there. And this is a research community supported by NSF. And you can see our website at netsvo.org, which by fall, we should unveil a brand new, better designed website, we hope. And the goals of the NetsVO is to facilitate teaming for this workshop sponsored by NetsVO is to facilitate teaming, discuss vision for resilient and intelligent next-G systems, and look at high impact research areas. We will not discuss solicitation. So this is not an NSF webinar. This is something by an outside organization. So there is an NSF webinar which talks about the solicitation, and that will be posted up on the netsvo.org website along with the recording of this, which we are recording now. And here's the disclaimer. Any opinions, findings, conclusions, or recommendations expressed in this workshop are those of the participants and do not necessarily reflect the views of the National Science Foundation and participating organizations. So this is a community-run thing. So Peter Vetter gave me this nice slide to describe the topic today, which is the Rings Partners Working Group. And the idea is that we'll have university researchers awarded projects with researchers sponsoring industry and government working with NSF. So there should be feedback going back and forth. And ideally, this workshop will help facilitate that first through the first 2 hours, which will be sequential panels, and then the breakout rooms. So the agenda is panel 1, Peter Vetter from Nokia Bell Labs will moderate, and it'll be about an hour. And we have these wonderful folks from Gavin Horn from Qualcomm, Sumit Roy who's now at the DoD, Harish Viswanathan from Nokia Bell Labs, Shilpa Talwar from Intel, and Kumar Balachandran from Ericsson, and I apologize for mangling names. And the second panel will be moderated by Pete Gupta from UCSB, Alberto Valdez Garcia from IBM, Ranveer Chandra from Microsoft, Ayman Naguib from Apple, Nada Golmi from NIST, Miriam Simsek from VMware, and Philippa Gill from Google. Then we will have the breakout sessions, and they're from 2 to 3. Now, if you look down, I haven't opened them up, but after the second panel, I will open up the breakout rooms, and everyone should be able to go to the breakout rooms on their own. They should be able to pick and choose their breakout rooms. So you can go back and forth, but we will have some moderators for the breakout rooms. For the lightning talks, that will probably be me moderating the lightning talks, and basically you can come in and come out of that. But in the lightning talks, folks will be giving 3-minute talks about their research, and the goal of the lightning talks is to look for teaming. Then we will have more specific breakout rooms that you can go to. We're going to have test beds and data sets, which will be moderated by Manu Gosing from Northeastern University. Resilience and security, moderated by Henning Schultz-Rini, and I apologize for mangling your name, Henning, from Columbia University. Network intelligence and autonomy by Salman Avestimer, and again, I'm mangling names, from USC. Novel spectrum management from John Vuran, University of Nebraska. Scalable device to edge to cloud, moderated by Carly Jo Wong from Carnegie Mellon. And merging digital, physical, virtual worlds, moderated by Misha Shaw from UCSB. So, house rules. Each panelist will discuss their vision before opening up to Q&A. All participants will be muted unless the host unmutes them. Please post your questions in the chat. So basically, the idea is if you have a question, post it in the chat and we can call on you, but we may take a bunch of questions that are similar and ask them in one form. And I'm going to put out a poll or a form, which we'll put in the chat to let us know which breakout room you would like to join. But honestly, you should be able to join it yourself. So we will see about that. Especially if you have Zoom desktop, the latest versions. And if you have any issues during this, please email me. So with that, I'm going to stop my share and turn it over to Peter Vetter, who's our moderator.
Okay, thanks, Katie. And also thanks our Pete for facilitating this first workshop here. The reason why I'm moderating this is that for Rings, we want to set up a similar virtual organization. We're actually doing something very unique here. For the first time, we have such a large sponsored program between government and industry, and an opportunity to really, with a large research community, think collectively about the next generation networks and systems that will be deployed in a decade from now. And in order to maximize the outcome, we want to also then create such a research community and really set it up around a virtual organization, have workshops, hopefully in person, say once or twice a year, but then also interleave with webinars like this is an example of it. So, and why do we do this? And I actually, Katie already showed it a bit in the diagram. There is a feedback loop. We are eager as industry partners and as government partners to work with the awarded research projects. And it's not only because we're putting in money, it's because we're really eager to learn from you what you have to bring, and we want to bring an industry and government perspective. And what is also unique about the program is the diversity of industry partners. We have web scalers, we have software stacks, we have semiconductors, we have system vendors, and we have government organizations. So diversity of perspectives, and each of the partners have world-leading industry labs in the US with renowned researchers that want to work with you. And so today we want to give a first flavor of what that can bring by giving you a perspective on what are the research questions that keep us busy in the panel. And you can probe with questions, and hopefully that will be a source of inspiration when you start drafting your proposals. So with that, I'll kick it off by then giving the floor to the 5 first panel members, and I'll take them alphabetically by the name of their organization. They'll do a 5-minute statement, industry or government vision statement. Some of them may have prepared a slide or so, and then after that we'll take questions. And the way we want to do this is you have posted your question on chat, but we will unmute you so that you can actually ask the question and also ask a follow-up question. And the goal of that is then that we hopefully identify your interest also, and that you afterwards can connect and team. All right, with that, Sumit Roy was the first in the alphabetical list of organizations, so take it away.
Thank you, Peter. So just for context, I'm currently an IPA working for DOD, the Office of the Undersecretary of Defense, R&D, since sometime in 2020, and leading a research program which is called Innovate Beyond 5G. And as part of my program, we are partners with the Rings solicitation. So let me reflect, DOD's and my specific program's interest. I think the 2 key terms, of course, are R&I, resiliency and intelligence. And it should be of no surprise to most people on the call that to DOD, from the perspective of adopting 5G, which is deemed as one of the key modernizations that the government, particularly the DoD, is undertaking proactively. And I will talk a little bit more about really the exciting new difference that I see within the US government vis-a-vis this next evolution of networking technologies. So with the proposed uptake of 5G within broadly government operations and specifically DoD networking operations, both the sensitivities and the promises to network resilience, and as you can guess, or as in any short reflection will underline that the DoD is really a multinational. In terms, it's a government analog of a multinational company. Most people forget that, or sometimes forget that the DoD's operations is really restricted to the continental US. Most of the operations are outside the US, and hence the ability to design networks would not just work in benign or comfortable circumstances, but actually can what we call operate through various non-benign, whether it's a modeled or acceptable interference, or more accurately when you have hostile interference. Okay, so amongst a gamut of operational scenarios, the ability for say any DoD network, notably one that uses 5G or beyond 5G, the ability to provide guaranteed services is paramount. And as you can guess, with the emphasis on not just high throughput services, but inclusion of services which are mission critical, more reliable, they provide low latency, ultra, higher reliability, includes a large number of potential, autonomous devices. We fully expect that in many of DoD's networks, we will be leading users of, non-human, the endpoints will be the sensors, of various types, not just low-end sensors as is commonly, highlighted within sort of commercial cycles, but very expensive high-end sensors. A lot of mobile vehicles and which are roboticized autonomous operations or semi-autonomous operations. So in summary, the role of those two elements of rings, resiliency to operational scenarios which vary a lot, and the role of increasing intelligence, I personally fully expect that DoD will lead use cases, will provide use cases. And for those of you who are not aware, it would be useful, you could go online. The DoD is being proactive. For the first time, I mentioned to you what is different this time, that traditionally the US government has been a sort of a passive down the line consumer of networking technologies. It has let all, mostly industry and the standards group define standards. And once they have been largely defined based on commercial ROI considerations, the DoD goes to adapt it and retrofit it. Here's the big difference. This year, in fiscal year 2021, the DoD has already selected a set of bases, 4 of them. There'll be another 7 coming in FY22. So up to $1 billion, US $1 billion of investment, where at each of these bases, a total of 12, the DoD will act like a private LTE network operator or owner. Of course, the vendor, and there are already many vendors who have been contracted, as well as applications and enhancers of 5G, actually get to use a 5G testbed, which is beyond what commercial providers, the AT&Ts and Verizons are doing outside to us, for us. So you're going to see, because of DoD's proactive investments, an acceleration of 5G standalone. And these will happen on DoD basis first, ahead of others. So this is what is really different and is exciting. There's significant investment in accelerating. And the idea for this is quite obvious. By getting into the game early, so to say, the DoD eats his own cooking, we provide an opportunity for DoD to work with industry to modulate and impact what happens in, say, release 19 of 3GPP onwards. So in summary, this is a very significant, I think, difference by the US government and by DoD in how it treats its role as a major consumer and now influencer of technology and standards. And I will end with that and come back and field questions.
Okay, thanks, Sumit. I'll hand it over now to Ericsson, Kumar.
Yeah, thank you, Peter. Yeah, I think I'd like to echo what Sumit just talked about. To a large extent, we have developed 5G to take on tasks that are well beyond traditional telecommunications workloads. Specifically to address critical use cases that are more demanding in terms of the reliability and resilience that is needed in terms of how available systems are, what their failure modes are, how they react to faults, disturbances, errors that may crop up because you have complex software and hardware systems interacting with each other, and so on. And in general, if you look at the themes that are prevalent today in terms of where wireless network development is leading, we see that there are the themes of cloudification, where a lot of the functionality is moving towards virtualization of network functions, greater programmability in the network, the ability to separate out concerns in terms of how we deploy services, the use of potential use of network slicing to address specific needs in terms of the quality of experience and the quality of service that end users are able to get. There is also an anticipated demand in terms of the level of trustworthiness that you can get from networking, in terms of how does an end user or a service get assurance in terms of the security posture of the network as such, as well as the level of reliability and the performance that you can demand out of the network over time. How do you build, for instance, high availability systems end to end when they have to depend on wireless networks as a basic mechanism in being able to connect subsystems, and to a large extent, these sorts of essential building blocks that we build into networks that can provide some level of certainty and in the level of reliability that you can get out of networks can effectively allow turnkey deployment of new use cases, specifically those to do with industrial automation, to do with trusting networks to handle transportation needs, to the extent of providing mission critical support for, say, public safety and disaster relief, for instance, to be able to get a greater degree of integration with more digitalized and programmable physical representations of virtual representations of complex systems. And to a large extent, I think what we are looking for is from the viewpoint of security assurance, service availability assurance. We are looking at solutions that can be built on top of confidential computing, the use of secure identities and protocols that are able to identify both software components as well as be able to verify hardware implementations across the board, and to be able to also be able to automate network monitoring to the extent where you're able to get a visibility into the operation of the network and be able to get enough information out of the network to recognize the performance of the network and to be able to react to changes that are happening on an ongoing or a real-time basis. So from that viewpoint, I think if you want to build resilience into networks, then you will need a fair degree of intelligence and automation in the system to be able to do that. And that is basically our focus. I think I will stop here.
Okay. Thanks, Kumar. And going with the alphabetical order of the partner organizations, it would be now for Intel. So Shilpa, the floor is yours.
Hey, can you hear me?
Yes, we can hear you well. Thank you.
All right, so I have some slides. I'm the only one who prepared some slides. Let me share my screen. Can you see my slides?
Not yet.
No,
No? Okay, sorry. Let me try again.
okay.
Share screen. And here.
Yay, now we can see it.
Oh, great. All right. So, I mean, first I just wanted to give a summary of, our thoughts on the RINGS program. We believe, network resiliency and intelligence is becoming more and more important, and it's becoming a cross-disciplinary area. So it cuts across compute, communications, AI, and sensing. And so, it's not just wireless communications as we've done in the past, and it's a very hard cross-disciplinary area, 6G. And so we wanted to work with universities to come up with some fundamental innovations in these areas. And I did create a vision type of slides because, Peter, I think you asked for sort of a vision. And this is sort of quick and it's my personal view. So sort of don't take, this as Intel's view, it's perhaps Intel Labs view. So what we've seen in from 2G to 4G, we've been trying to get higher and higher data rates. And that was mainly for human consumption, entertainment, gaming, etc. And then in 5G, we introduced, machines to be connected to the network. And then we introduced two different classes of traffic, massive machine type communications, as well as ultra reliable low latency communications to accommodate these machines. And as a result, the networks had to be more flexible So they became more software defined, and that transition is going on right now. Higher speeds were still important. EMBB was still important. We added lower latency enhancements to the air interface and introduced edge computing as a node in the network, such that you can do processing closer to the data, and so you can get more real-time responses. And then the idea was to connect billions of devices and things. So if we have to look at 6G and trying to understand what's going on in academia as well as industry, I think 6G will potentially support wireless autonomous systems, and it will require the intersection of not just compute and connectivity as we saw in 5G, but also AI. And so now the software-defined networks sort of transform into intelligence-defined networks. We want to have higher reliability and resiliency in the networks in order to meet the needs of autonomous systems. And we move from connectivity of devices and things to the autonomy of devices and things. So in order to do this, the networks need to be not only agile, scalable, but also have resiliency and intelligence. And I'm gonna skip this slide. And I just want to say that we believe that the advancements are gonna come in the intersection of disciplines to support 6G, and the disciplines of communications, networking, distributed computing, AI, and machine learning sort of are going to cross. We need a new fundamental framework to work across all these disciplines. And we are doing we have some research directions in the lab. I don't think I will have time to go through some results, but we're looking at intelligence-defined networks, which is sort of the intersection of communications and AI. We're also looking at distributed compute across the wireless edge. So being able to take the compute workload and move it intelligently from the device to the edge to the cloud. That's an important problem. And then we're also looking at multi-com networks, so convergence of cellular and Wi-Fi. That's been an ongoing quest, but I think with the edge, it makes it much easier to converge networks. And then finally, we're also looking at distributed machine learning over the wireless edge so that we can do intelligent processing of the data. So I think I'll end here. Thank you.
Thanks, Shilpa. And you get brownie points for using slides there. Actually, very interesting. It's good. Okay, then we move over next in the list. That would be Nokia Bell Labs, Harish, and I hope you don't have a thunderstorm coming over your house.
Hey, thanks, Peter. So are you able to see my screen?
Yeah, there we have it.
Okay, so I just have 2 slides as well to walk through what we think will be the needs of the next generation communication system and how that drives the technologies that we need to work on. So let me start by asking the question, what do we want from the next generation? In Nokia Bell Labs, we think in terms of expanding the human possibilities or augmenting the human in 3 different regimes. The first one being augmenting our experience, which is about bringing the physical location close to us, increasing our proximity in a very rich, multimodal, multisensory way. So examples of the use cases are sort of listed there. Creation of high resolution, dynamic digital worlds would be where I think we are headed, and that in turn drives many different use cases across both the consumer and us people as workers. So if you look at what this means for the networks that we need, it translates into high capacity and low latency networks. Low latency being not ultra low, but relatively low latency. So all the different streams are seamlessly connected to each other. Synchronization for these digital worlds are achieved. both outdoor and indoor. The next dimension for augmentation in our mind is augmenting human intelligence. So far, we've relied on the networks for information, but going forward, we believe that we will rely more and more on technology and the network to even augment our intelligence. So one of the major ways that we achieve this is through ambient sensing. So we have a much better sense of what's going on around us, including sensors to monitor physiological parameters, and these will be represented in these digital worlds. And what we need for this is pervasive sensing and also the processing or machine learning and artificial intelligence based processing to make sense out of all the information that's gathered through the sensing. Then we have augmenting the human productivity. So this is everything to do with how we make use of robots and other machines, offloading the tasks as required, allowing the robots to interact with each other to create even bigger systems that can do all the tasks for us as efficiently as possible. And this requires more flexible and agile networks. We may need more direct interconnectivity between the devices. We need to be able to deploy networks rapidly in different scenarios, recover from failures. These things are required for augmenting our human productivity. Finally, that's not the only set of requirements. We want all these requirements to be available globally. It has to be sustainable. Energy efficiency is going to become quite important. We, of course, want to be as affordable as possible and resilient to any kind of disruption, including node failures, weather patterns, crossing disruptions, etc. So this I sort of label as multidimensional efficiency because it's energy efficiency, cost efficiency, efficiency for resilience, etc. So then how does this all translate into technologies? So if you look at the first requirement on capacity, I think there's really two different ways and focusing primarily on the wireless network here. We have massive MIMO that's proven to be quite successful in increasing the spectral efficiency, going from 4G to 5G. And we believe that there is opportunity for further increases in spectral efficiency and reducing cost of massive MIMO systems. So that, including foundational basic research that can advance this technology, especially when it's applied to new spectrum bands. And clearly more spectrum is another way that we are going to be able to provide this high capacity. And new spectrum is not easy to acquire, and so spectrum sharing is going to be a very important theme. And here, I think what we should aim for is a faster timescale spectrum sharing. We have now systems like CBRS that are based on slower timescale processes, but in the future, we could envision faster timescale sharing. In order to enable pervasive sensing, one approach is to enable the cellular network infrastructure to also do sensing, not just communications. And we have the opportunity to make sensing truly widespread and pervasive if every access point, every base station is able to not only do communications, but also do radar-like functions. I think there's a lot of potential for new applications and use cases to come from that. And the wider bandwidths that we envision for the next generation is going to help with the sensing by improving the resolution of what we can do. Flexible and agile networks means that we need to improve the network architecture through better orchestration, simplification, eliminate unnecessary duplicate functions, have better orchestration capabilities, implement as microservices in the cloud. These are all the capabilities to make it really flexible and agile. And of course, all of that has to come together with security, trust in the network. And privacy will be very important to maintain as we go into the future with a lot of cameras and other kinds of sensors in the network. And then multidimensional, like global coverage or energy efficiency, these things may require us to build other types of networks, non-terrestrial networks integrated with terrestrial for global coverage, more small-scale networks to meet the needs for resiliency in the sense that they work independent of the connectivity to the wide area network, which we sort of call sub-networks or network of networks. So these are the ways that we can improve resiliency and the number of use cases. Finally, all of this will be supported by machine learning and artificial intelligence, the new tools that we have to make networks better. So we think there's a lot of interesting research to be done in making, in exploring how AI ML can help, not just in network optimization, but also even in the design of the next generation of the air interface, how we can better use the spectrum, reduce cost, and increase all kinds of efficiencies. Thank you very much.
Great. Thanks, Harish. And yeah, Shilpa, now you have to share your brownie points also for the slides. So Gavin, you're last but not least. Keep us in suspense whether you use slides or do.
Yeah, I have slides. That's right. They working?
Yes.
Where's the slide going? Yeah, or I'll just leave it in this mode. Yeah, so thank you, Peter. So I'm just giving you a brief, I guess I'll try to a delta from what Harish did. I do think, though, it is important to look at what happened in 3GPP up to now, because I do think looking a little bit back on how 5G has evolved is obviously going to be a good indicator of how 6G was evolved. So basically, the first release 15 of 5G was focused on massive mobile broadband, and basically the primary use case was a smartphone. And so that was the initial intent, but obviously the system was designed with a lot of flexibility in mind. And so what's happened now in release 16 and 17 is this further expansion to other use cases such as mission critical, also using things like unlicensed, multicast, etc., as well as adding features like positioning. And so we've seen over the last two releases this addressing this more new verticals, new kind of deployments, etc. And now in the next month or so, we're going to have the first workshop for release 18. And we're going to see that then things that are looking more on 5G advanced type features, such as full duplex, etc., and release 18, 19, 20 are more likely going to be the foundation for 6G. So if we look what happened in 5G, the last few releases, 12, 13, 14 of 4G, were basically a lot of the foundational technologies in 5G happen there. So the work is happening now, and obviously it's being introduced now. Maybe 5G or 6G is a more clean slate version of the same thing, such as slicing is especially a good example. So if you look at actual what features were done in 5G, then a lot of the basic foundation for 5G was intending to do a very flexible network. So we looked at flexible slot-based framework, scalable numerology, massive MIMO. These were things that were basically designed to allow you to address many different kind of use cases. Similarly, on the network side, network slicing, disaggregated RAN, service-based architecture also allowed a network that would then be also flexible to deploy on these different kinds of use cases. And release 16, 17 is basically just increasing those things, increasing those use cases, looking in improving the features like power saving mobility with things like wake up signaling and mobility enhancements. Obviously, I said high precision positioning, but then also the new use cases like NR Lite, which was allowing you to reduce capability UEs. On the other hand, we were going in the other direction of extended reality, so looking at addressing issues like what's called XR and AR and what kind of features will help. So release 16 and 17, as I said, expands on this, and now longer term research, the research that's going to sort of potentially be the foundational work for 6G will include features like full duplex. Obviously, there's a big drive to now add AI, ML explicitly into the network, especially in the RAN, looking at new bands and looking at things like green networks and RF sensing, new kinds of features that will then enable a more 6G type kind of applications. If you look at it, and this is pretty similar to what Harish had, we're looking at how this interfaces and how these interfaces are changing, especially from the human side. So obviously we live in a physical world, but more and more sensors and more kind of devices that we interact with are now being attached to us. And so we have a much more digital world, and we're interfacing with this digital world, and it's allowing us to do things and understand things and create these ideas of digital twins. And so we're seeing this move from a more physical to a digital world to sort of enable us. On the other side, virtualization has helped now with this turn this physical world into the features like spatial computing, etc., have enabled things like XR, AR, augmented reality, etc., where they're now augmenting our world. So between those two, between these three, this interface, this is going to basically fundamentally change how we interact with devices and sort of fundamentally change the platform that a human being is going to look at as far as we're moving away from the smartphone to this much more immersive experience. So when we break it down, and I think Harish covered a lot of these topics, but I'll just cover the delta. When we break it down into what the actual primary areas Qualcomm is looking at, obviously we're looking at the scalable network architecture. How do we extend disaggregation further and virtualization? I don't think that 5G basically, for the most part, just took a existing network and put it on a cloud. And I think we've got a long way to go on how to actually fully exploit the cloud. We have not really looked at cloud features and made 5G look more like, or 6G potentially look much more cloud-wise. So we obviously have the edge, the cloud, and all those interactions, but that fully utilizing the cloud functionality has not been there. But we want to do that at the same time, looking at different kinds of deployments to address these kind of demands. So we're looking to push the kind of topologies available. As we said, also, we will need more capacity for 5G, for 6G and beyond. So we're looking at more radio designs for megahertz and terahertz. And obviously that also introduces new applications such as RF sensing and energy efficient RF and all these new applications, which will allow us to have a much better feeling for the world and enable this digital/physical interaction. Of course, part of this includes this communications resiliency, and obviously that's been covered pretty well. I think wireless AI is also now something that's basically just starting to be looked at from a 5G perspective. People are looking at more going towards a data-driven design. So actually using data to help design the network, but of course, actually using ML explicitly to improve your user experience, as well as then using it to improve your services. So how can AI, ML in the network basically be allowed to help your applications run better? How can they improve the interaction between the device and the applications and the user? Coordinated spectrum, I think Harish covered pretty well. Like obviously, we will need more spectrum, and we do want low band spectrum, obviously for coverage. But as I said, we also need to now look at the interaction with high band spectrum in terms of these new types of use cases. And at the end of the day, I guess it comes down to this merging of worlds, like this physical, digital, virtual world, how all of these interact and how this platform fundamentally changes how we interact with the world, and obviously all the devices around us to enable these new kind of use cases. So these are the main use cases or main areas that Qualcomm is currently focusing on, to sort of looking at what 6G is about. By the way, I should say with a grain of salt, if I did this speech at the same stage at 4G, we would have had like a completely different list and what actually happened in 5G. So obviously, new use cases and new kind of problems are going to emerge in the next few years. And I think also with the deployment of these kind of private networks and mission critical, we're going to learn a lot more, and we're going to obviously see, okay, what is missing, what do we have to do to make these networks more usable. Thank you.
Okay, thanks, Kevin. And again, thanks to all the panel members for sharing their perspectives. We're going to open the floor now for questions, and I'm just making sure at the moment, so please post your question in the chat. So we have like 20 minutes left. I'm going to pose an icebreaker question, but please insert your questions, and we'll then open the mic so that you can ask the question. So the icebreaker question, what is the problem in 5G that you want the research community, the university research community, to solve for 6G? The one big hard problem that you want the research community, the academic research community to address for the next generation, what would it be? Any first taker?
Yeah, I can go first.
Harish?
So I think that the main problem, if you want to solve one problem, I would say is still about reducing the cost of equipment. I mean, you might think that it doesn't matter when you take into account the overall deployment cost, the fiber network, etc. But I think if we had a lot of resources today for improving 5G, we would really focus on how to create the lowest cost solution for achieving the same sort of high spectral efficiencies, reliability. So essentially making it affordable. And the second point along the same lines actually is also improving the rural coverage, and cost and the business case plays a critical role here. And so driving down the cost is also a way to improve rural coverage. So these would be the number 1 and 2 problems, very closely related.
Thanks, Harish. Any other takers on this?
I have a
maybe
slightly
have 1 or 2, and then
different
there's questions coming in. Okay, Kumar, maybe?
Yeah, so I have a slightly different take on this. I think one of the things that we have done so far is address traditional telecommunication services in all the generations that we have built. And to a large extent, the way 5G ended up departing from our conventional wisdom was that we admitted the possibility of using wireless networks for more mission critical tasks. Now, where we have actually perhaps not, progressed far enough is in being able to break down what the requirements of various services are in terms of the level of performance that you should desire out of these systems. So you really, if you want to use telecommunications networks for more high availability mission critical systems development, then you have to be able to break down the requirements of your use cases to the extent where you're able to prove that your system performs according to the requirements of the service that you're trying to introduce. And this is where we really need a level of work where we are able to get the mentality of bringing in compliance into the picture, so that you know what you're building towards and what performance you need out of the system. And then, I mean, inevitably systems are going to fail at some point in time because of various reasons. So then you have to be able to build resilience into the system to be able to decide how is your system going to react when something goes wrong, and how are you going to learn from this and be able to modify the behavior of the network going forward. Can this be done on an ongoing basis? Does it require refactoring some of your development? And in general, what is the role of machine learning and artificial intelligence in being able to analyze the posture of your system on an ongoing real-time basis and be able to create much better performance out of networks for specific purposes.
Okay. Thanks, Kumar. In the interest of time, I'll not go around the entire panel for each question, but I'll keep it a bit succinct because there are some questions coming in. So I want to give enough airtime to that. And taking them in order that they're coming in, Henning Schutzrinne actually has a first question. So Henning, we will unmute you so that you can ask your question.
Thank you. And thank you for all the perspectives. I have to say, I was a little disappointed that this seemed like a updated 5G symposium. I'm in that, as in everything was now AR and VR and ML. This doesn't seem research. I mean, this seems like projecting the industry forward. Is there room in your perspective? I know industry has to do 6G research because that's what pays the bills, but carriers after all do that. But I mean, I think Monisha mentioned this as well, this seems awfully narrow and awfully just replicating the systems that we've built for the past 30 years. And it seems really difficult for academics to make a difference in a system which is already so complex it is beyond the capabilities of most academic research labs to do anything with, except kind of do black box research. So I'm curious what your perspective is of taking a more expansive view that actually challenges the 6G vision that seems to be floating around, as opposed to just amplifying it.
Who wants to
Okay,
take
let me.
it?
Yeah, let me take that. So, clearly with 5-minute statements, what people may want to hear may not be addressed by any of us, but I thought Henning and to Manusha that there are enough leading or trailing indicators in what was said to suggest, and I think there should be a collective view. There are very significant technology challenges at from the radio layer to the RAN layer, to architectures and services. And I think this has been mentioned. So I'm not sure why, this gets the impression it is incremental. I mean, if you ask me, so let me make a concrete observation, right? From a DoD perspective. DoD presents some of the oldest, hardest problems. Perhaps, a lot of academia is not attuned to it, but the fact is, cellular is by and large still a planned network. And the key operational circumstances that DoD faces is significantly unplanned scenarios. So let me make this even more concrete. Massive MIMO, a favorite academic topic. Well, what do we know about it? In terms of actual benchmarks, okay? It has been proven that you have large-scale MIMO at mid-bands with over, several hundred, megahertz. Well, does it scale to millimeter waves where you have, a gigahertz of frequencies and you want to, to get, because of the form factor, scale the number of, phased array elements by another order of magnitude. More importantly, for DoD applications, can you put the darn thing on mobile platforms, on vehicles and on UAVs or, LEOs and make it work? So the spectrum issues, I really, think that for people looking for hard problems, there are many, many hard problems, and this should be of interest to the academic research and the industrial research community. And I could go on, about more, and I'm sure others will. Thank you.
Thanks, Sumit. Gavin, you maybe want to give?
I would echo Sumit's comments, but I also think that there's a lot of, dimensions that we can look at. Like, I do think there's a long way to go before AI and ML is actually commercially viable. I do think there's a lot of foundational research that's happening in that area that's sort of very helpful to us, at least what we're looking at, just to sort of see how we build it into our devices. I think fields like RF sensing and all those kind of areas are so new and so different that we've got a long way to understand, okay, how do these work? And just in general, I think that there's a lot of issues. The other areas that we would love to see like advanced research in is like homomorphic encryption, confidential computing. How do you actually make the system on both the device and the network more secure? How do we sort of handle and manage data? I think that's very unknown at this point. And I do think there's a lot of very interesting, very difficult problems that we would love academia to solve, because they seem very, very far away from commercial use. Another area which I didn't mention was like quantum computing. Obviously, that's going to potentially have some kind of interesting impacts, and how post-quantum security is going to work. So these are areas where we, for the most part, rely on academia to solve the problems.
Yeah, and we can add that we're always open to new ideas for the vision. I mean, if someone is able to articulate, more interesting vision, we're happy to listen to that. It's not like we are set in stone with this.
Harish, I'll cut you off. We have 5 minutes left, and Shilpa, you didn't.
Yes, I just wanted to say that, I've been working in this area for a while, and, understanding the rate, reliability, latency, trade-offs, and being able to manage spectrum resources efficiently is a hard open problem. I have not seen a solution to, if I have certain requirements in a network, how do I use my resources to get, maximize the number of users that can meet their quality of service? And that's an open problem. And, we've done rate and reliability, rate and latency, but having this whole understanding the trade-off between each of these metrics is, I think, an important area. And if we can have a better handle on that, that'd be really good. That'd be really interesting.
Okay, thanks, Shilpa. So we have 5 minutes left. Let's try 2 more questions. And I see, Jeff Reed, you have asked 2 questions. I suggest you can choose 1 question in the interest of time.
Okay, thanks. How do you think that the experience from ORAN will influence 6G standardization?
Okay, let me take that, and let me also take that in the context of the earlier comment about 5G or 6G. So so there is a tendency to look at 3GPP as the overarching envelope of how this technology will evolve. Well, somebody has already said a few things that need to be reemphasized. One is that and I think Manisha probably intends that next G is beyond just cellular, and there's many both the ways that verticals, industry verticals, private networks are emerging. These would be customized networks. So all the problems are not about the next generation cellular. Okay, so technology components will arise from what 3GPP does, but it is very clear that based on 5G, we will extend well beyond that. And so that's a segue to Jeff's question. ORAN is really an industry consortium. It's 3GPP has its own, it's an open standard. It has its interfaces. ORAN is suggesting a different set of interfaces. Okay, so whether that goes back to a future 6G standard is perhaps not the most relevant question, right? That we will have market segments which are increasingly more customized. So you have the global wide area cellular network, sure, but we will also have customized networks. And for that customization, this is an interesting question that you may well have other standardization agencies which play or industry consortiums which play a pretty critical role. So the short answer is this may not flow back into a wide area 6G cellular standards, but we may have standards for various industry verticals. And I fully expect that this is an interesting question for the future.
Thanks a bit, and Shilpa, you have
I mean, as I understand it, ORAN is implementing 5G specifications, and it's more of an implementation specification in disaggregating the hardware and software resources and defining the interfaces. So, and the thing is that they're using intelligence as part of the framework, and we'll learn a lot from developing solutions from ORAN, and then potentially standardizing some of the ideas into 6G in that time frame.
But what I meant was, Shilpa, that
yes.
ORAN is not the only industry consortium. There are other small cell consortiums, so there will be customizations based on the 3GPP specifications. Right. And I expect that trend to actually, I think, be more pronounced.
So we are at the top of the hour. Katie, I look for some guidance from you whether we allow one last question.
I think we can fit in one last question.
So maybe Monisha, we open the mic for you.
Oh, thanks. I guess, can you hear me?
Yes.
Okay. I guess my question has been answered, but if I may sort of change the question a bit, sort of teeing off what Sumit and Shilpa says, that when I read the solution, by the way, I'm not representing FCC at this webinar, I'm representing my academic side. So don't take anything I see as being representative of FCC's position in any way. So when I read the solicitation, I was hoping that there would be more of a discussion about moving away from, so the stacks as we know it today. So even ORAN, right? ORAN is taking 5G and opening it up. how about looking at the entire network from the other way around? Suppose you were designing a network to be open from scratch. What would you do differently? And that is, to me, where I was hoping I would see a lot more discussion about, as to just trying to move away from the silos we've created in the world of networks today, which is, you have the cellular world, you have the unlicensed world, you have the IoT world doing their little small data rate things. And not really a question, but just more a comment.
Gavin?
Actually, that's my favorite topic at the moment. So yeah, I think if you look at the platform, I think that, as I said when I was talking, I think if we look at how 5G was designed, we basically just took the 4G architecture and put it on a new platform. We did add service-based architecture, but I do think that there's a lot to do if we make this, if we leverage cloud a lot better. There's a lot more things we can do, and I think sort of redoing the whole thing from scratch is pretty much the only way to get cloud to be properly integrated using the platform. So I think from that, and then also the device itself, like the device is now thought of as like a single device. But if we really look at how people use their phones today, and obviously it's going to even change more in the future, you now have a phone with a smartwatch, with the potentially with the goggles in the future, and also the other accessories you have. So the device is no longer a device. It's probably going to look much more like a network going forward. And I think all these dimensions are then things that we have to now, okay, how do we actually address this in a way that's going to make the device and the network much more scalable? How do we sort of merge this edge, cloud, and device platform into something that actually gives you a much better experience? We also have to deal with things like the connectivity versus the compute storage trade-off and these kind of things. These are going to be very interesting problems to solve once we sort of really try and leverage the platform that's going to emerge as cloud becomes much more pervasive towards the edge.
Okay, thanks, Kevin. And I think now we will wrap it up. A very interesting panel. It felt like the debate was just warming up, so we will see a lot more discussion, hopefully going forward. Thanks again to all the panel members. Thank you for the very good questions. And Katie, over to you again.
Okay. Thank you so much, Peter. And now I'm just going to hand it over to my co-chair, Arpit Gupta, who will be moderating panel 2. And by the way, I am reminded that these discussions can be continued in the breakouts rooms. What I will be doing, just to remind everybody who's here, is I will be opening up the breakout rooms, and you should be able to choose your own breakout rooms. I do not have to assign you. You can just, once the breakout rooms are open, you should be able to join yourselves. But I'm going to hand it over to Arpit. Arpit, are you here?
Yeah, I'm here. Thank you,
Okay,
Katie.
great.
All right, so let's get started with panel 2. There is no specific theme or agenda for these different panels. It's just continuation of the discussion that we are having, but we now have more set of people representing different.
Hi all. Arpit, have you frozen? Miriam, Ranveer, Philippa, it's nice to see you. Arpit, are you there?
Hello, Katie.
Hello.
Yeah, I'm also not able to hear RP.
Okay.
Problem on his side.
Yeah.
Somebody says that we need a resilient network. Okay, so what I'm going to do then is, until he comes back, this is, when I was teaching networks to my students, I said during the pandemic, this is a real stressor of the network. So I'm going to ask folks to introduce themselves, and I'm going to go left to right from my screen. And actually, I'm going to ask you all, if you can, when you if you can change your name, if you can add your company to your name, that would be cool. So first I'm going to introduce Miriam Simsek, who's from VMware. Is that correct, right, Miriam? Could you introduce yourself briefly?
Yes, I just changed my name. Thanks, Katie.
Sure.
I am Miriam, Chief Scientist of Advanced Technologies at VMware, which I joined about half a year ago. And before that, I was actually with Shilpa at Intel Labs, and my previous life was mainly in Germany at Technical University Dresden, coordinating the 5G Lab Germany as well as in Berkeley. And I'm one of the co-initiators of the tactile internet community in IEEE. So we started with immersive experiences back when 5G was introduced. And today I will be representing VMware and VMware's vision for NextG and the Rings program. Thank you, Katie.
Thank you. Harpreet, over to you.
Yeah, thank you. So we have Alberto as well. And what I will do is quickly do an introduction to the panelists, and then I'll hand over to each of them to give their vision pitch. So we have Alberto who's a principal research staff member and manager of RF Circuits and Systems Group at IBM. We have Ranveer. He's a chief scientist of Microsoft Azure Global and partner researcher at Microsoft Research. And we have Ayman Naguib, sorry if I'm getting it wrong, is principal wireless architect with Apple. And we have Nara. She's a NIST fellow and is currently the chief of the wireless network division in Communication Technology Lab there. So, with this basic introduction, I'll hand over to the panelists. They will be talking about their vision and set of problems that they think are interesting. I'll start with Philippa, and this is in no specific order. I have random ordering at my end. We'll start with Philippa.
And Harpreet, I just want to mention that we also have Philippa Gill here from Google.
Yeah, so I think, okay, I thought I introduced her, but I guess that was
Sorry,
the time
my bad. Or maybe I misheard.
No
okay.
Worries. All right. So I can't hear Philippa. Can others hear her?
Test.
Yeah.
Okay. Okay. So this is the vision presentation.
Yes.
Okay. Sorry, I haven't had to present in Zoom. I'm trying to find how to share my screen.
So at the bottom, there should be a share screen option for you.
Okay. Let's see. Oh, I'm in the web client.
Oh, I see.
Oh. Okay. All right. I might have to.
Yeah.
Okay.
Yeah, slides are not critical, so you can just talk about the ideas.
Okay. Yeah, so hi, I'm Philippa Gill. I've been at Google for just under a year at this point. Kind of recently got roped into this Rings stuff. And I want to talk about kind of enabling next generation applications with NextG and the network edge. So many of you guys are probably familiar with the core network. You see the standard diagram with all the data centers and links between them of large cloud providers and content providers. And what I really want to highlight today is that in addition to this core network, Google actually has about 3,000 different edge compute nodes. So these are nodes that might be in enterprise or telco networks that allow Google's computation to actually be happening at the network edge. And I wish my slides were actually projecting. But so you can think about applications now can be deployed.
Philippa, you can email me the slides and I'll do them for you.
Okay, I can actually, I wonder if I can.
Or we can, actually, I'm wondering if we could move on to somebody else and you can email
the
slides and then
let's do that. I'll send you a link.
Great, thank you. Sorry.
Okay, so I guess we can move to next panelist, Miriam. Can we have you speak?
Let me first unmute, and I hope you will.
Yeah, we can hear you.
Able to see my screen as well.
Yeah, we can see your screen.
Okay, I don't know which. I guess you see the presenter mode.
Yes.
Okay, this should be better. Yeah, thanks, Arpit. And actually, I just want to spend a few seconds on this slide to highlight what we do see as a difference between the different generations, and it won't be a 5G presentation, no worries. So as several of the previous panelists mentioned, the previous generations were all about humans and connecting humans and data, and how to connect, how to compute and store up to 4G. With 5G and the introduction of machine communication, we introduced new functionalities with respect to sensing, storing, and acting, which enabled us a new service besides data, which was the introduction of autonomy. So we have set the first steps in 5G towards autonomy, but we have been also quite overambitious, so we cannot claim 5G is done and ready and mature at its full scale. And that's maybe also addressing one of the comments I think Henning had in the previous panel with respect to why is it incremental? One of the reasons is we haven't solved all the problems in 5G, but we, and this chart here shows a little bit of a maturity of various approaches that have been considered in the context of 5G, and the color coding shows the maturity level basically. With respect to massive broadband and cloud native solutions, as well as pervasive connectivity, we have introduced quite mature solutions and that are still evolving. However, we have also considered various other aspects in 5G, such as openness, which was discussed in the context of O-RAN, as well as programmability. And we have identified the need for autonomic networking, as well as time-sensitive communications. I think Shilpa mentioned she hasn't seen any really useful metrics and solutions in the context of mission critical and URLLC type of problems in 5G. So the maturity in these problems is not at its full scale, but we have done a lot of steps towards it, and we have identified 5G as a generation of many firsts. However, it remains to be completed. And as I said in my introduction, we got quite excited with this new types of communications, such as URLLC and massive machine type communication in 5G, that we introduced the concept of the tactile internet as well, actually several years ago now, where we wanted to enable real-time remote control and physical interaction at long distances at a global scale, actually. And in order to do this, we think there needs to be some gaps filled, but for the next G vision, if we want to provide a very high level vision, and we have to look into various technologies and how they are evolving, because one of the key problems in 5G was that we might have been maybe sometimes too initially quite overambitious and have not looked at the maturity levels of technologies and their availabilities. And that's why we say we should look into the evolution of various technologies with respect to the radio, compute, web, data, as well as operations, because we are now talking about a completely different concept and the merge of compute, cloud, telco, networks. And we have heard the concept or the expectations with respect to immersive experiences. So the societal needs and the society's reaction and demand on these technology evolutions is also a factor to be considered in defining the next G vision from VMware's point of view. And therefore, what we are doing at VMware is, on the one hand side, we are trying to fill the gaps with looking into programmable solutions, autonomy network solutions, as well as introducing time-sensitive fabric solutions. And of course, as a cloud company, we look into cloud and networking, not completely disruptive cloud and networking solutions, but also into some solutions that are directly connected to the telco, such as the telco cloud. We are already providing cloud solutions to various service providers. Of course, there is very active research going on with respect to AI, ML, and security. And these are just some very high-level directions that we are working at at VMware in order to tackle the next G vision and define the next G vision from various technology point of view and come with a unified solution. And I have been asked to provide also some expectations and challenges that we see for NextG and the Rings program. I think it was Harish in the panel which said we want to have solutions at a global scale, global connectivity. And yes, we are talking in NextG about the connected world and how to enable it, as well as new novel immersive experiences without specifying them at this time for specific applications in future. And for that, we are aware of the fact that NextG systems will be extremely complex. We will be talking about complex systems and extremely heterogeneous in terms of requirements, technologies, expectations. And therefore, we think that we are now talking about the confluence of wireless networking and cloud, and that the consideration of the edge to cloud continuum will be of interest because we will need more compute on demand at various scales in an ad hoc manner. And we will be also looking into the merge of the physical and digital worlds, which comes with a most likely completely novel requirement space. Therefore, 5 NextG systems will have to be able to cope with this complexity and heterogeneity and be able to offer new services as well as support legacy services. We don't want to create an orthogonal generation. In addition to this, we are expecting resiliency, security, scalability, adaptability, and autonomy for NextG systems such that we can support these various technologies and heterogeneity. And therefore, we think that we should have an end-to-end consideration and solutions. And hereby, I'm not saying we should all the research should consider solutions from the cloud to the mobile device. However, what would be interesting is to really understand if we are proposing a solution with respect to resiliency on one network. I will complete in one sentence. I'll complete in one sentence. Okay. If we look into solutions or proposed solutions for one specific network domain, how does this impact the overall resiliency, overall performance? Would be an interesting research agenda. And let's be disruptive and rethink everything. Let's not limit ourselves with what's available today and look into novel fundamental research directions.
Okay.
Thank you.
Thank you, Miriam. I think in fairness for all the other panelists, let's try to stick with this 5-minute timeline for all the vision talks. So next we'll move to Alberto.
Hi, Arpit. Thank you. Yeah, my name is Alberto Valdez Garcia. I work at IBM Research. I'm one of the researchers working on 5G and integration of that with various software and AI technologies. I'd like to speak a little bit about my background, and that would be a motivation to some of the key points that I'd like to make. I'm an RF circuit designer by training, but I believe in industry academia collaboration, and I believe in multidisciplinary projects, and I think that is how we can move forward. Early in my career, even though I came from a hardware background, I was given the opportunity to participate in the 60 GHz standardization effort, the first millimeter wave standard, and I was able to make connections with many of the wireless researchers and really witness how standards come into play. That was important to bring awareness of how technologies are created. Later on throughout my career, I've been a liaison to Semiconductor Research Corporation, and I'm currently one of the liaisons to the SRC JOHN program. Some of you in the audience may be familiar with that. I was myself sponsored by SRC in my PhD. So I believe that the collaboration between industry and academia is key to make these initiatives happen. Recently, my team was part of the NSF Platforms for Advanced Wireless Research, and we were able to transfer some technology capabilities, particularly in millimeter wave and beamforming, to the Cosmos team and the current 5G testbed in New York City. I do not have a slide, so I'm not one of the ones who are going to get brownie points. But I think that the overall key the key priorities, right, or the key objectives for 6G, we see common themes across the prior speakers, so I thank them for their effort. I'd like to, in the remaining time, address some of the questions that were sent to us by ARPIT recently, and give some key messages and takeaways, I think, for the academic community about this. The two, I think, keywords that I would like to bring up in this panel for the academic community is to think about end-to-end and to think about in a multidisciplinary way. That is, I think, the message that I like to bring up. So one of the questions from ARPIT is why we think that doing this resilient next generation network is fundamentally hard. The answer, I think, is because we are introducing new technologies at that accelerated pace. So we are trying to make something robust at the same time that we are trying to evolve it, or that we have high appetite for evolving it. And we cannot really accomplish this for individual network layers in isolation, right? We have to think about an end-to-end approach and doing this by having a multidisciplinary solutions to these resiliency problems. Specifically in IBM, some of you may not be aware of this, as we may not seem to be an obvious player in the telecommunication space. IBM currently has commercial technologies that are part of the 5G infrastructure, whether it's software-defined networking, orchestration of the all-RAN at the top level, and it can be all the way down to the hardware. Where, for example, my team has recently developed something that we call a software-defined phased array platform for development of directional communications applications in the millimeter wave space. If one of you is interested to learn more about that, feel free to contact me. So the second, another question from ARPIT, what problems do we like the community to work on? So I think we have some examples as to what problems. Let me speak about, from my perspective, about how do I think is the how of that solution important, right? So we have examples of the how, of the what. How do I think those problems should be solved? I think that a key, one of the key missions of programs like this is not just to solve the problems or come up with innovative research, but it's also to educate the next generation of engineers and researchers, right? There is this mission of education from the academic community. And through that mission, what I would like to encourage professors attending this call is to give, through the problems that you solve, the students the experience of working on and prototyping their solutions from an end-to-end way, go across disciplinary boundaries. If you work on the network layer, team up with the hardware layer folks. If you work on the hardware, team up with the AI and ML researchers, and really challenge the students to prototype solution and test them end to end, not in isolation. When you really try to test an idea at a given level of the network in an end-to-end way, you uncover other projects, you bring up valuable learning. And fortunately, today, we don't need to say, one of the speakers earlier today, Henning, he was asking questions, how can problems be solved, with a single professor? I think let's not think about that way. Let's think about addressing the problem as a community. Test beds are a key part of 5G research now. We have test beds such like the PAWR test bed. There are others. If we think about as a community and really be part of broader solutions at the testbed levels, I think we can come up with compelling concepts to address the challenges that have been outlined by speakers before. So I leave it like that for now in the interest of time. Thank you.
All right, thank you, Alberto. So I think we have slides from Philippa. Katie, I guess you're gonna share your screen, and we can have Philippa go through those slides.
Okay, test. All right, cool. Thanks for dealing with the technical glitches here. So today I'm happy to be talking to you about enabling next generation applications with NextG and Edge. So I'm Philippa Gill. I've been at Google for about 11 months now, and I'm a research scientist. Okay, so next slide. So as I started before, many of you are probably familiar with this sort of diagram where you can see a content provider's network. You've got kind of your central hubs and your backbone links. But really, in the last few years, we've seen this progression too. If you switch to the next slide, please. We've switched to this notion of the cloud being everywhere. So it's not just your backbone data centers anymore. You've got POPs, you've got edge nodes and interconnects, and really bringing the compute much closer to people around the world. So if we switch to the next slide. And so this notion of having compute much closer to the customers is actually enabling new types of applications. So here on the left-hand side, we can see devices. So this might be your mobile phone or your TV, or traditional cloud endpoints in an enterprise network, so virtual machines and servers. And here applications are having to make trade-offs between where they put data and compute. So for example, if they're quite latency tolerant, like for example, some data intensive application that's not sensitive to latency, they might want to operate in one of the main cloud data centers. So the latency is a bit higher, but the compute cost is going to be lower. But an application like mobile gaming, where you want very low latency, but you're still doing more computation than you'd want to do on the mobile device, you might want to locate that in the customer edge. So if we switch to the next slide, and really, next G is just amplifying this. So increasing the amount of data that's being produced and the amount of services that we can support. So some examples of these, if we go to the next slide. So, like I mentioned, things like mobile gaming. So very latency sensitive application. You're now running your games, on a node that you're connected to over the network. And the interesting thing about gaming too is that it's not just high compute requirements, but it's also using things like GPU and graphics processing. And so you've got kind of this heterogeneous population of compute nodes. We can also think about data streaming applications. So, streaming your high def video, but also interactive applications like, telemedicine is kind of canonical high impact one. Also, I think during the pandemic, many of us missed live music performance. So you can think about remote musical collaboration, things like this, where having low latency and high bandwidth can let you do kind of more interactive and interesting applications. And then finally, for IoT, you've got these low powered devices, but with this connectivity, they can now leverage compute that's in the cloud. So using AI or ML to configure your thermostat to do monitoring in different ways. Basically by using this network connectivity to amplify the amount of computation. So next slide. And really, I just want to highlight, there's all these really awesome applications that we can think about with, edge compute distributed around the globe, close to users. Like I mentioned, there's trade-offs. So it's interesting to think about, can we automatically navigate these trade-offs, figuring out where to put compute and data in order to optimize latency and compute costs, also understanding where to place data and how to move data to be resilient. So understanding, what sort of failures you'll be tolerant of. In terms of kind of privacy and security, thinking about controlling data sharing. So you've now got your application distributed across all of these edge nodes and all these POPs and backend data centers. Where is the data? How are you controlling its sharing, as well as isolating data from different applications? Can we go back to the slide? And on the topic of resiliency, so thinking about this very distributed application, you now have a huge attack surface. So you want to manage security, thinking about things like zero trust. So being able to operate even if you don't trust all of the components of your application, automatically and seamlessly recovering from disruptions. And topics like verification of network functionality, making sure the network and applications are going to do kind of what you'd expect. So yeah, these are kind of the applications and different research problems that we're thinking about.
All right, thank you, Philippa. So we can move to the next panelist, Ranveer. Can we have your slides?
I won't use slides, Sapit. Yeah, I know I'm from Microsoft, but I won't use PowerPoint. So yeah, it's nice to see everyone. And yeah, just to introduce myself, I'm right now leading the networking research group at Microsoft Research as well. I also lead a new initiative called Research for Industry, where we are bringing in different areas of computer science and doing research, looking at the future of different industries, including agriculture and food and financial services, retail, supply chain, and others. So I'll start by just talking a little bit about at Microsoft, what do we envision as the future of 6G, the next G vision? So when we think of the next generation of networks, we believe it's going to be higher speed than what we have now and lower latency. These are the two promises of 5G. But in addition to that, it will have much more. One, it will be much more resilient, the kind of things that Felipa, Miriam, and Alberto were talking about. It'll be much more resilient with respect to security, with respect to recovering from disasters and so on. And another thing is it's going to be much more pervasive. We are not going to leave anyone else behind. It's going to connect the rest of the world as well. And towards that and it's not just connecting people, it'll be connecting things in remote areas. Many of you might be familiar with my previous research, which was on FarmBeats, which we shipped as a product. It was on data-driven agriculture, bringing data to some of the most left behind industry, in this case, agriculture and farming. And we were able to show how data and AI can help farmers be more productive and practice sustainable agriculture. It's a shipping product. But then there again, we've just scratched the surface because there's no connectivity in the middle of the farms. And we believe that with the next generation networks, we'll make these networks much more pervasive. The next question, which Arpit asked us to address was, well, this is the vision. How do we get there? And what do we believe? How will we get there? We believe to get there, we'd have to bring in all modalities. We can't just be thinking that this is terrestrial, this is Wi-Fi, this is space. We need to bring in all the modalities that exist, space, 5G, TB white spaces, CBRS spectrum, all of it. Bring all the infrastructure that is there to offer, including cloud, including edge, including those remote end devices. We need to bring all of that. We need to bring in the entire spectrum, all the way from lower frequencies, from VHF, all the way to higher frequencies, including terahertz. And then the key thing is we need to make the entire thing programmable. We are scratching the surface with software-defined networking, making parts of it software-defined. We're seeing now RAN is getting more software-defined. Can we make the entire end-to-end system more software-defined? Like what Alberto was talking about with software-defined phased array. Can we make software-defined spectrum? Can we do software-defined in space? Making the entire thing programmable, that will help get to the systems which are much more pervasive and much more resilient. What is Microsoft doing in this space? Well, as many of you know, we've been doing research and we are heavily invested in research. We are working with many of you in academia for a very, very long time. We've published a lot of papers on data centers, on edge, on spectrum, on 5G, on edge computing, a lot of that. In addition to that, we've recently launched a new group within Microsoft, a new product around Azure for operators. You might have heard about two companies we acquired with Affirmed and Metaswitch. Those are very significant acquisitions, especially investing in the 5G core. That said, Microsoft is very partner-led. This is mostly to get our own ecosystem, our cloud, more optimized for operators, but we are working with partners to build these solutions for 5G and 6G. We're also working on connecting people. For example, our Airband initiative, through which Microsoft has pledged to connect 3 million additional people in the US to broadband by 2022. We are bringing in our own technologies. We are working with academics. We are working with partners to get there. We are also investing in industries. As many of you know, with FarmBeats was one with agriculture and food. We are working in energy, with supply chain, with retail, and we are working tightly with many of the customers, many of the Fortune 500 companies to help them with their digital transformation. And when you think of the digital transformation, a key part of it is the network. If you can't get the data in the cloud, you're not really realizing the full potential of the digital transformation. So that said, how do we plan? So I'm very excited that we are part of the Rings program and all the other partners that are part of it. And would love to work with all of you who are on this call and who are not as well, who'll watch the recording on this future of NextG. We would like you to work on all layers of the stack, all the way from hardware to software, to the spectrum, to infrastructure, to manageability, the programmability, and not just that, also the applications that could be lit up on top of this. We believe that if you could light up this really high-speed, resilient, low-latency network worldwide, this would disrupt many of the industries the way we know of it today. And we would like to work with you. And the way we want to work with you is we will provide you with resources. We are building the edge stack. We are building the Azure for Operators stack. We want to bring it to you. We want to provide you access to the cloud, to the latest in technology that we have. And not just that, we would like to connect you to the customers that we work with. As many of you know, we've been working with several academics on FarmBeats. And as you know, as part of that, we have this FarmBeats monthly meetings. We bring in customers to that. And we want to expand that even here to the networking, to this next G space, come partner with us. And we're really looking forward to working with you as you really disrupt the future of networks.
All right, thank you, Ranbir. That was very inspirational. So I'll move past the baton to Ayman. So you're muted, Ayman.
Yes, I'll try to get my brownie point. I have one slide, and I think that's the benefit of me being the last speaker. I don't have to say much, but I just do have one slide that I hope to complement.
Ayman is next to the last.
Yes.
Oh, come on. So I hope to basically with that one slide to complement I think the excellent points that the speakers in this panel and the previous panel made. And if you allow me to share my screen.
You should be able to share your screen.
Okay. Just give me 1 second.
I could point out that Ayman and I went to school together and we both look the same as we did umpty years ago.
I certainly you. No, me no.
And same here. Shilpa, I also went to school at the same time as Ayman.
Thank you.
So Ayman, you get a brownie point for that.
Yes, exactly.
Okay, here we go. Do you guys see it?
Yeah.
Okay.
Yes, it's visible.
Good. Okay, so I'm just gonna jump straight to the point that I want to make here is which is this. We're looking at communications between 2 points or multiple points. So there's a connectivity space here that's defined by. Let me actually start the. Okay, there is a connectivity space here that's basically defined by different modes. One is data rate, the other one is massiveness of the information that's being transmitted on that connection, the latency of the connection, and the reliability of the connection. One of the key, and also the fact that you're going to have that connection is going to exist in an environment that's going to have somewhere between 1 or 2 devices to an environment that's going to have hundreds, not even like in case of factory floors, is going to have like thousands of devices. And of course, each one of the devices is going to have one or more radio that's talking over 1 or more networks. So, coming from Apple, basically the idea is just the point that I want to leave with you is that we're going to have different applications. There's going to have different data rates, different latency, different reliability, different data size requirements that will be using 1 or more of those radios over 1 or more of those networks. And the key things to keep in mind is that when when we try to solve for a problem, for example, you're trying to design a link that is going to give me the best data rate possible or optimize the latency, is that we try to do that while we're not paying attention to the fact that what's the impact on the other connectivity modes, and ultimately what's the final impact on the application that we're trying to, or the applications that we're trying to address. Just to give you an idea, for example, if you look at health monitors, it's basically the key thing is reliability, and also the fact that these links or these connections will be carrying a massive amount of data. And when I say also massive and also at the same time private, because this is the other thing that we also need to keep in mind. For example, augmented reality. The game here is data rate and latency. Look at like sensors or robotics. It's reliability and latency. Autonomous driving, it's everything. And all of these also we have to keep security in mind. For example, and I'm not talking about security in terms of like encryption or like, I'm talking about security all the way down to the physical layer itself. I'm sure many of you may have seen that interesting ad or kind of like YouTube video where like thieves stealing a car from somebody's driveway by simply going next to the person's home and putting like a receiver and a relay that relayed the signal to somebody standing next to the car, and he managed to drive away from the car with the car. So so basically, how in that example, how do you, for example, make sure that the car knows that when it picks up the signal that the key fob is really close to where that person is, right? So so in some sense, we have to take security into account when we also look at each one of those eigenmodes. Okay.
All right, thank you, Ayman. And we now have the last panelist, Nara. Go ahead.
Please stop sharing.
Yes.
Hi, everybody. So I guess I'm gonna not discuss a vision. There are lots of interesting visions that my co-panelists and the previous panels shared with us. And no matter what vision you believe in, whether you believe it should be incremental or disruptive, or you want to solve a very mundane problem like me connecting 5 times to the Zoom today to rejoin every time my screen froze, or if you believe in XR or VR or some of the very kind of novel and cool applications out there, there's lots of interesting problems and hard problems to solve for you guys. So do not be afraid. And if you need a vision, pick one and go for it. If you don't need a vision and you have problems to solve, that's fine too. So we at NIST do many things related to the Gs. And again, as far as we're concerned, the Gs are the Gs. There's after 5G, there's 6G, could be 10G. It doesn't matter. So the Gs are it's a continuum and a sort of there's always going to be the next G. So what we care about really is continuing to innovate and advance. In terms of our angle is the metrology in support of communications. We do, like the DoD, provide some interesting use cases. For example, we work heavy in public safety, communication research, and advanced manufacturing, understanding how communications support and could advance some of these domains and these use cases. But fundamentally, we are interested in advancing metrology and using metrology for communications. So from propagation, yes, propagation. I know it kind of seems kind of very mundane, but we do need to understand how, from a wireless point of view, signal propagate. So we know that now we're looking more in terms of the measurement, the data, and how we're going to learn from it in terms of to improve intelligence and resilience. So that's some of the focus areas for us. We do have interesting facilities in terms of antenna, test beds, and anechoic chambers, reverb chambers, and the like. And we also have work going on in terms of security, end-to-end security, and securing the communication systems. So I think that's sort of what I wanted to mostly touch upon. We do have the story of 5G or 6G or the next G. It's about collaboration and partnerships. Like some of you noted, it's difficult to solve these very big problems and hard problems all by ourselves and in single organizations. And that's why we at NIST like to partner with industry, with academia, and that is really our motivation for joining the Rings program, right? Because we want to partner with the community in order to help in terms of measurements, in terms of models, in terms of data sets for use to develop the next generation. So if you don't mind going to the next slide, so I can tell you a little bit more about some organizations. So these are our, again, we innovate in terms of the instruments and the measurement instruments. Sometimes we are available and you can get them off the shelf from commercial entities. Sometimes they're not available, and we go off and develop those, and then we work with companies to use them. And next slide, please. And this is sort of, a few years back, we launched this NextG Channel Model Alliance, which is a user community. To date, it has over 180 participants, and the focus has been on propagation models. We would like to expand that to touch upon other additional data sets in terms of models. So there could be a community for folks to share measurements and models. And I want to leave you with the last is really about the partnerships and the facilities that NIST could be that has available. And I'll stop here. And so hopefully we have some time for questions.
Yes.
Thank you.
Thank you. All right, thank you. So others, if you have questions for the panelists, please feel free to use the Zoom chat to post your questions. And while we're waiting for other questions to come in, I just want to push the question that I had. That like there were 2 points that were made in this panel as well as the previous panel. One was about machine learning and AI being very important in context of next-gen networks. So if any one of you can talk about the actual challenges of applying machine learning in this context, and like how the broader academic community can actually pursue these problems, given that we don't have access to the data or the type of data set that is required to pursue this type of research. And the second, I load this question with the second question as well about cost, that like we're talking about 5G or 6G networks in context of reaching out to the last mile or reaching out to the underserved, underprivileged areas. Then what is fundamentally new and different about these next-gen networks that gave us hope that the prices can go down, the cost can come down, and we can get better connectivity in future?
I can take a stab at least some of the points, if you don't mind. So when you talk about machine learning and people know, for example, that you need a lot of training data, right? And think coming from from a device manufacturer, and given what Apple has been kind of stressing in the last few years, that the privacy and security of the user is a key important point, is that the question always is that how do you basically improve machine learning and at the same time make sure that the user data and is secured and private, right? So a lot of the applications that basically that involve users data, we make sure that it doesn't leave the phone, right? But if somebody were to propose or kind of like suggest a use case that would require that people sharing some of the data, right? So, I would think that advances in things like homomorphic encryption, I think like Gavin, I think said the same thing, is key. Because right now, as far as I know, the kind of thing that you do with homomorphic encryption is still limited in scope. But if you really wanted to do more things and kind of like widen the scope of how you can use it, I think that that's something that has that people in academia need to look at, so that if we, for example, find that there is a compelling reason for some of the user private data to leave the phone, and of course the user has to opt in, right? Then we can basically find, here is a way that your data is going to leave the phone, is going to be secure when it leaves the phone, and it's going to remain secure when it's being used on the network side. So that's definitely one key thing that I think we definitely need to look at. The other thing that we also see is that a lot of, or at least, you know, I'm not a machine learning expert by any stretch of the imagination, but a lot of the work that we see is that a lot of these techniques, okay, you know, there is a problem, or this is the classification, or it's decision A versus B, but why? You don't know. You don't know that the network decided that this is a desk, not a kind of a round table, because of what? So a lot of the things that we would like to do using machine learning for in the network, for example, trying to understand why the network failed, right? It would be very important to come up with techniques that when the, you know, the engine or gives a decision, or, you know, is that we understand why that decision is being made.
Yeah.
So.
Like to briefly expand, Arpit, I think you touched on a very important point. The gateway to, or the gatekeeping factor to AI is the availability of data. So this community, including ourselves, the industry participants, have to think about how to share data sets, how to enable a program like this, come up with data, not everyone having their own small data sets, but how to aggregate as a larger pool so that everyone can benefit from larger amount of data and doing the AI. So we have to think about that.
Can I add something
Yeah, sure,
to this?
Sure.
I think there are several aspects, and machine learning or AI is really a broad topic and needs to be considered from different angles. One of the issues is that machine learning was not developed for solving networking or systems optimization problems. And we are currently just seeing solutions with basically plug and play solutions where available tools are used for certain networking or 5G problems. And I think it would be of interest to identify what can be solved, which problems with respect to systems and networking can be solved with machine learning. How can NextG benefit from AI? On the one hand side, maybe for this we might require the development of novel machine learning tools and solutions. On the other hand, we need to distinguish between intelligence for the network and in the network. While we need to create maybe new network solutions in order to support intelligent machine learning approaches, we have to develop new solutions, machine learning solutions, to solve network problems. And one more thing that I wanted to add in this context is also that in the Rings program, we specifically use terminology with respect to autonomy and autonomics, and this does not have to be only AI or ML related, but can be other tools such as control theory related solutions can also be provided. I hope I'm fine with saying this from the Rings program point of view. Thanks.
Yeah, I think like in general, whatever we discuss in this panel is not view of NSF. So this is, you know, like the view of each of the participants itself, and not reflection of what NSF solicitation for Rings program is. So I think I have one more question, and this is something which relates to the question that I was asking earlier, that we're talking about a framework where we are trying to support high data rates, you know, like really good performance. We also want to strike a balance between the intelligence that we can extract from the network and the privacy that we can offer. But also we have to worry about the cost, right? And like, you know, as Ayman was pointing out about homomorphic encryption, that's costly, right? Yeah. So where, like, you know, where do we strike a balance here? What are your thoughts on this specific topic, that we are struggling with multiple dimensions to the problem, and each of them have their own set of challenges. And I think, like, you know, cost is something we have to fundamentally think about deeply as well.
Take a first shot at that, Arpit. So, you know, I think, so even the things I was talking about, where how do you make it more pervasive? How do you connect the 3 billion people who do not have internet access? And cost is a key player in that. And the more we talk of AI, we know we are increasing the cost of it as well. But if you think of the future of networks, which is going to be completely self-organizing, self-managed, that is going to bring down the OpEx of your systems quite a bit, right? So even though a lot of the AI we are talking about is in the R&D phase, where I think over the next 10 years or whatever the phases, we are going to be spending a lot of money in that future of the internet. We believe the future of the network is going to be require much less human intervention. It will operate flawlessly most of the time. And so if you're thinking of that, I think in the future, all these investments will be captured through systems that the OpEx is lower. So your systems, the cost of the system will go down. The other part is the CapEx investment, where again, AI can help. And we are talking of things like spectrum, things like reusing antennas, things like reusing infrastructure in an intelligent way, right? When you're talking of, if you have to reuse, like what we did with all the dynamic spectrum access work with CBRS and other parts of the spectrum, you need your system to be more intelligent. And the more intelligent it can be, the more spectrum reuse can happen. So there are techniques which AI can enable to bring down both the cost of CapEx as well as OpEx.
Thank you. Anyone else wants to chime in into this discussion?
So there is a question from the audience from Eugene Wasserman. In the context of resilience, how does one define operating flawlessly?
That's a good research from itself, right? I think the definition will evolve because we'll start with something, and I think the definition will evolve. Right now, I think we all had different definitions we put together in terms of security, in terms of reliability, and various other metrics. But I think the definition of this will evolve, and it could be different in different contexts. Flawlessly in one context could be different than flawlessly in another. So, but I think this is an interesting research problem by itself.
And I don't think it's going to stop at next year. I think it's going to continue, because as the application evolves, other use cases rise, and what was good enough for the current use cases is not necessarily going to be good enough for the for use cases 10 years from now. I mean, I was so thrilled the first time I got my 56K modem to work at home, right? And right now, I mean, my AT&T line is just like 50 megabit per second, and I keep cursing AT&T every day. So,
all right.
So,
go ahead.
I just briefly wanted to say, just bring back the comment from one of the previous panelists, right? It's important to bring these more like high-level statements on flawless or resilient into concrete specifications for every use case. And I think this is where end-to-end experimentation comes into play, right? If a researcher comes and said, okay, I'm really going to prototype what is required for a rescue vehicle to operate in a network so-and-so, that experimentation leads to specific requirements, right? As researchers, we have to drive to concrete goals. Otherwise, I agree, it's very difficult to say what's flawless. Mm-hmm.
And maybe to second a little bit what Alberto and Renwe said, I think we are also very open to receive new definitions. Like there is an entirely new field on reliability theory. Maybe definitions from there can be applied to NextG and within a specific given problem. And we would be very open to learn and see new definitions also.
Yeah, that's actually a good point. One of the rising and kind of like trending areas of investigation for 6G, for example, is joint communication and sensing, right? So a lot of the work there is that people are trying to basically, send the same signal and do two things at the same time. In a lot of these applications, what's good for communications, what you define as a failure for communication, right, is not necessarily a failure for sensing, because, it could be that you send your data got lost, but I was still able to range with you. So I know where you are, how far you are, even though the data that I was sending you was lost. So how do you define, for example, an error event in this case, right? So these are the kind of things that I think people need to keep in mind, because, a lot of time when we try to do this to look at these techniques is that we try to basically use the old definitions of what, I'm going back to my physical layer days here, is that what a collision event is, or what an error event is. But in reality, that's not really the case. Yeah, the data part failed, but the sensing part didn't. So, I mean, if there is such a thing as like half success, half failure, I mean, you know.
Cool. All right. So I think like, yeah, we are getting close to the end of this session. I have still one question for the panelists. I'll take the liberty of extending the schedule a bit. But before that, if you have questions and if you're not able to, discuss those questions in this panel, you feel free to join the breakout sessions where we'll have more in-depth discussions on specific themes. But I think I'll highly encourage you to participate in those breakout sessions. Will be fragmented there, but I think that will be a good opportunity to discuss those points in detail. And before we end this panel, I just want to ask the panelists a question about role of formal methods in design of these resilient next-gen networks, right? So where do you think what type of fundamental challenges and problems do you envision one needs to address with the formal method tools?
Yeah. I could start again, Arpit. So, even with one of the things we realized is that in a lot of our systems, we use formal methods after the fact. Like just to tell you some ideas, for the one of the systems I have designed was the Xbox wireless controller. So if you're using an Xbox One, the wireless controller protocol is something that I have designed. We designed it, and after the fact, we were using formal methods to see what the errors were. Similarly, in our data center networks, we have a few papers that have recently come out which talk about the use of formal methods in data center network protocols. That again is usually we've designed it and then we are seeing what problems there are, especially looking at whether an implementation meets a spec. But I think there is that, of course, we should do and we should do more of. I think we haven't done as much in the wireless space and we need to do more. But I think the other thing is designing the protocols itself using first principles, using formal methods. I think if that can be enabled, I think that would be huge. And so, yeah, for people who are in this space, I think there is a huge opportunity to be able to reason about the protocols that we end up using.
Cool. All right, so I think this brings us to the end of this panel. I will thank all the panelists for sharing all the insights with us. And I also want to acknowledge that this is one of the most diverse panels that I've ever participated in. Forget about moderating, just participation-wise as well. This is one of the most diverse panel that I've seen. Thank you all panelists, and I'll pass the baton to Katie, and she'll give us some directions on what the next steps are.
Thank you so much, Arpit, and I really enjoyed that panel also. So now we're on to breakout rooms, and if everybody looks down at their Zoom bar, they will see breakout rooms, or you should see breakout rooms, and you can join whichever breakout room you like. So I have a message from Arpit. So you can see that there are the breakout rooms are listed as lightning talks, test beds and data sets, resilience and security, network intelligence, novel spectrum management. So please join a breakout room of your choice. And if you cannot join the breakout room, you can chat with me and I can assign you to the breakout room, but you should be able to join yourself. Any questions?
So are we as industry panelists encouraged or allowed to participate, or
Of
are these
course.
meant only for
I would say encouraged.
Oh, okay, great. Yeah, I thought maybe this was for teaming up for academia. We should stay out. But yeah, I'm happy to participate. Okay.
Oh, that's wonderful. That's wonderful.
Right.
Okay.